going to do notes for lesson 5-4 in your book, Evaluating Algebraic Expressions, which begins on page 289. Evaluate algebraic expressions. I can use the order of operations to evaluate algebraic expressions for given values. Learn. Evaluate algebraic expressions. The variables in an algebraic expression can be replaced with a number. Once the variable has been replaced, you can evaluate or find the value of. That's something that's really important. You might want to underline or highlight that, because evaluate does mean find the value of. It means you're finding the answer of the algebraic expression. Suppose that x equals 5 in the expression 4x plus 2. The expression can be evaluated by replacing x with 5 and simplifying according to the order of operations as shown. So here we go. 4x plus 2, and we go ahead and we substitute x 5 for the x. So it becomes 4 times 5 plus 2. Remember that whenever you have the number, the coefficient, next to the variable, they are saying you must multiply 4 times x, or 4 times the value of x. And in this case, it's 5. So 4 times 5 plus 2. We've replaced x with 5. Then we do the multiplication according to our order of operation, because multiplication comes before adding. So 5 times 4 is 20 plus 2. And we add those together and we come up with an answer of 22. So the expression 4x plus 2 is equal to 22 when x equals 5. I want you to look at this over here, talk about it. Can you evaluate the expression 2x plus 5y minus 1 if you know that x equals 3? Explain your reasoning. So in this case, we have two variables. We have x and we have y, but they only gave us the value of one of the variables. So can we evaluate this expression? No, we cannot, because we only know the value. Oops, I'm sorry, I forgot. No, we only know the value of x and not y. Continuing on, page 288, page 288 at the top, example 1. Evaluate one-step algebraic expressions. Evaluate the expression 6b when b equals 1/2. Remember, 6 times b when b equals 1/2. So 6b, we write the expression down, and then we go ahead and we replace b with 1/2. So instead of 6b, we have 6 times 1/2. And then we go ahead and we do the multiplication. 6 times 1/2 would equal 3. So the value of this expression is 3. Plain and simple. All we have to do is we replace or substitute, and then we do the math that we need to do. So let's go on to check. Evaluate x over 6 when x is 33. Remember, this x over 6 is also showing division. So it could be 33 divided by 6. So in this case, we would go ahead and we would do x over 6, and then we would substitute the x for the value they gave us. So it would be 33 over 6, or 33/6, or 33 divided by 6. And at this point in time, when we do the division, 33 divided by 6, we would say we could simplify this by 3's. So we would divide by 3, divide by 3. So 33 divided by 3 is 11. 6 divided by 3 is 2. And then we could take this, it's 11 over 2, or let's put it into a mixed number. How many 2's are in 11? That would be 5 with a half left over. So 5.5 would be the answer. Going on to example 2. Evaluate one-step algebraic expressions. Evaluate the expression x plus y when x is 3/4 and y is 2/3. So again, let's go through the steps. X plus y, we have the expression. This is what we're working with, x plus y. And then we are going to go ahead and replace or substitute our values that they gave us. So x equals 3/4, so I'm going to put 3/4 in place of x. And y, they gave us the value of 2/3, so I'm going to replace 2/3 or substitute y with 2/3. So now my problem is 3/4 plus 2/3. And from what we remember with adding fractions, we need to make sure that the denominators have the same number or a common denominator. So in this case, 4 and 3, we know 12 would be a common denominator. So we're going to rewrite these fractions. Instead of 3/4, let's use 9/12. And instead of 2/3, let's use 8/12. So we have common denominators. And then let's go ahead and do the math. Let's add them together. 17/12. We're going to add 9 plus 8 equals 17. And we have 12 as a common denominator. And at this point, we can take and we can make it into 1 and 5/12. So the value of this expression is 1 and 5/12. Go ahead, let's do the bottom one. Where it says check, the bottom of 288, check. Evaluate a plus b when a equals 5/6 and b equals 3 and 1/4. So we're going to go ahead and follow the steps from right above. I'm going to do a plus b, and then I'm going to substitute or replace. So a is 5/6 and b is 3 and 1/4. So at this point in time, what we should do is take a look, and we could take a look at this and we could say that we need to have a common denominator. So 5/6 and 1/4. Because if we're adding together, I can use this 3. I can put it over on the other side, but I can take a look at these two and say, okay, 6 and 4. A common denominator would be 12. So 5/6, I can create into 12. So 6 times 2 is 12. 5 times 2 is 10. Remember, I split this up to a 3 and 1/4, so I put the 3 here. And then 1/4, 3 times 4 equals 12. 3 times 1 equals 3. So if I take a look at this and I add all these together, I can go 3 and 13/12. And as I look at that, that looks a little strange because we have the number up above is larger than the number below. So I can take this improper fraction, and I can make this improper fraction 1 and 1/12 and add that to the 3 and make it 4 and 1/12. Another way you could do this if you did not want to split this up would be 5/6. And then I could take this and make this mixed number into an improper fraction. 4 times 3 is 12 plus 1 is 13 over 4. And in this case, it would be 10/12 plus 39/12. And that would be 49/12. How many 12s are in 49? That would be 4 and 1/12 left over. So we get the same answer. It just depends on if you're going to change this 3 1/4 into an improper fraction, or if you're going to split the whole number and the fraction apart and then answer. But 4 1/12 is the answer that you would have either way. Continuing on. I'm on page 289, example 3. Evaluate multi-step algebraic expressions. Evaluate, parentheses, 5x minus 4y, parentheses, divided by z to the second power. Now, we're ramping it up a little bit and making these a little more difficult, but we can do this because all we're doing is we're replacing. So x equals 4, y equals 1/2, and z equals 3. And then we're just doing the math, which we did in previous chapters, previous parts of the chapter. So let's go ahead. We're going to write the expression. Here's the expression that we started with. And then we are going to go ahead. Next step would be replacing. So 5 times x, or 5x, would be 5 times 4. 4y would be 4 times 1/2, because we replaced 1/2 with y. We replaced x with 4. So here we go, 5 times 4 minus 4 times 1/2. Those are in the parentheses. And then it said z equals 3. So instead of z to the second power, we have 3 to the second power. So here's the problem that we are going to evaluate. And with order of operations, what we would do is we would go ahead and do everything within the parentheses. And within the parentheses, then we have to think about, instead of subtracting first, we need to multiply. So let's multiply before we subtract. So 5 times 4 is 20. 4 times 1/2 is 2. Still within those parentheses. And then 18 would be the answer. 20 minus 2 is 18. And then on the outside of the parentheses, 3 to the second power. Remember, the second power means that you multiply itself, that number by itself 2 times. So 3 times 3 is 9. So within the value from the parentheses is 18 divided by 9. And so we would go ahead and do that math. And we would find the value of that expression, even though it was really long and looked very confusing with three different letters in it that we had to do replacing. We still were able to do it because we can do our math. We came up with a value of 2. Now, let's look at the next one. Check. So check is evaluate x over 4 plus 2, parentheses, y to the second power minus 3z, parentheses, when x equals 12, y equals 7, z equals 8. So here's our expression that we're going to look at. And so let's take a look and do this. Let's go ahead and do x over 4 plus 2, parentheses, y squared minus 3z. So we write the expression. Then we go ahead and we start the replacing. Oops, I'm sorry. We start replacing. So it says x equals 12. So I'm going to put 12 in place of x. And then I'm going to continue. The 2 stays, the parenthesis stays. Y equals 7. So instead of the y, I'm going to put 7 to the second power minus 3z, and z equals 8. So it's 3 times 8. So if we take a look at this, we have to go ahead and follow PEMDAS, follow our order of operation. So we have 2. We keep that. We're going to keep 12 to the 4, 12 over 4 plus 2 parentheses, 7 times 2, so 7, I'm sorry, not 7 times 2, 7 to the second power. Let me finish that. 7 to the second power, 7 times 7, 49, minus 3 times 8 is 24. So 49 minus 24 is 25. So 2 times 25. we also have to use that 12 to the 4. I'm running out of room here. So I'm going to make an arrow and come over here. So my problem is 12 over 4 plus 2 times 25. Whenever we have a number outside of those parentheses, we need to make sure that we multiply. So 12 divided by 4 is 3, and 2 times 25 is 50. And when we add those together, we come up with an answer of 53. I want you to go on to the next page. Example 4, the top of page 290. Top of 290. I know it looks a little more difficult, but you will get through this. You'll do great. So here we go. Example 4, use algebraic expressions. The expression 1/2 a parentheses b plus c can be used to find the area of a trapezoid. So here's our trapezoid. Remember, a trapezoid has 2 parallel lines, and we have 3 different areas that we need to look at. We have one base, and then the height. What is the area of the trapezoid when A equals 9.8, B equals 12, and C equals 7? So we're using this expression, 1/2 A parentheses B plus C. And we're going to go ahead and write out the expression. And then we're going to replace and substitute A 2.8, B 12, C 7. So instead of the variables, now we have 1/2 times 9.8 parentheses 12 plus 7. So we would go ahead and simplify what's inside of the parentheses. It means we're doing our order of operation, our PEMDAS, so do whatever's inside the parentheses. 12 plus 7 is 19. And then we go ahead and we multiply. We can take here we have 1/2 times 9.8. So 1/2 of times 9.8 is 4.9, and we're going to multiply that by 19. 4.9 times 19 gives you an answer of 93 and 1/10 square inches for the area of that trapezoid. Now let's do this on our own. Let's check. So the expression, we're using the same expression. So 1/2 A parentheses B plus C. To find the area of this trapezoid, what is the area of the trapezoid when A is 3.7, B is 6.4, and C is 3.6? So I put down the expression we're going to use, and let's go ahead and start replacing them or substituting. So instead of A, I'm going to use 3.7. I'm going to keep the parentheses. B is 6.4, so instead of B, I'm going to do 6.4. And then instead of C, I'm going to do 3.6. And as I start to work through this, 3.6 plus 6.4 gives me 10. So inside the parentheses is 10. I still have 1/2 times 3.7. So I can do 1/2 times 3.7. And when I do 1/2 times 3.7, I'm going to go over here. There's more room. So 1/2 times 3.7 gives us 1.85. And I still have the 10 from here. So I simplified these two and multiplied. And then I'm going to now multiply 10 by 1.85. And I have an answer of 18.5 or 18.5 as my answer. And I'm going to put centimeters squared because we should have the label here as to what was used. Centimeters were used, we multiplied for that. Going on. I'm going to stop at the apply so you can do that in class.